Let's look at question number 16 from GATE Aerospace 2022. Consider steady two-dimensional incompressible flow over a non-porous flat plate as shown in the figure. For the control volume PQRS, the speed U free stream at section PQ is uniform and the speed at section RS is given by the function of y when n is a positive integer. The value of A0 for which the flow through section PS will vanish is being asked to calculate. To solve this, we will need to look at the continuity equation. And since the flow is steady, we can say that this term becomes 0. So we're left with double integral of rho v dot ds. Since the flow is incompressible, we can take the density outside and our equation reduces to v dot ds is equal to 0. And the density, since it goes to the other side, it becomes 0. So applying this equation in the control volume, let's look at the left hand side. We see that the integral is from 0 to the height h. The velocity is u free stream and the area is given as dy times 1. And since the area vector is outwards, the angle between the area vector and the velocity vector is 180, and so we have cos 180 degrees plus 0 to h with this function u multiplied by dy times 1, and the angle between the ds vector and the velocity vector in this case is 0, and we will equate this to 0. Taking the value of cos 180 as negative 1 and on substituting the function u, we get this equation, and on integration we get this equation. On applying the upper and the lower limits, we get u free stream times the distance h is equal to a naught divided by h to the power of n times h to the power of n plus 1 by n plus 1. And here we see that the h on both sides get cancelled and we are just left with a naught is equal to u free stream times n plus 1. Hence, the correct option is option B.